So welcome to our unit on trigonometry. Today we're really going to dive into trigonometry, the study of triangles. And our first goal, we want to focus today on what's called right triangle trigonometry. And I'm going to do things a little backwards today. Today, in this lesson, I'm going to start with a very concrete example. This is going to be our very first example. We're going to dive right into it. If you stick around to the end of the video, I'll get a little bit more into the kind of how this was developed and what it's used for. So kind of more of the hows and whys, I should say, later in the video. But right off the bat, we're going to start with a very concrete example. Solve for x. You have this right triangle here. It has a 90-degree angle. This angle is 30 degrees. This side has a length of 15. We could say like 15 inches if you want to. How long is this side? Is that even enough information? Well, if you understand trigonometry, this actually is enough information, and we can solve this without having to get out a ruler or a protractor or anything. This is enough information to find out exactly how long this side is. So let's break this into steps, and I actually want to start right off the bat with this 30 degrees. This 30 degrees is known in trigonometry as theta, the featured angle. We're going to say right here that theta is 30 degrees. Okay, theta is really just like a variable. It's actually the Greek letter T, but it looks like this. It's a variable to represent, so in a right triangle, of course, we're always going to have our 90-degree angle, and then we're going to have two acute angles. This here is 30 degrees. This over here would be 60 degrees. You can't see it. In right triangle trigonometry, we have to choose one of these angles that we're going to feature. All of our problems are going to revolve around this one angle, and here we're choosing this 30-degree angle as our featured angle, theta. So step one, we need to start with this triangle by labeling the hypotenuse, the opposite, and the adjacent sides. Now you already know, from Pythagorean theorem, you already know that the hypotenuse is going to be this side with length of 15. It's the side farthest away from the 90-degree angle, and it's also the longest side of the right triangle. Now the legs, we know that this side is called a leg and this side is called a leg. The legs opposite and adjacent all center around this featured angle of 30 degrees. Since this x is far away from the 30-degree angle, we say that it is opposite of the 30-degree angle. And now this side up here, that's really close to the 30-degree angles, we're going to call it the adjacent leg. So we have our adjacent leg is close to the 30 degrees. The word adjacent means next to or close to. This side over here far away from the 30-degree angle is called our opposite leg. Okay. And a quick note while we're here. These could actually be flipped. Let's say that we chose to make the 60-degree angle down here. Let's suppose we chose to make that our featured angle. Well, the hypotenuse would stay the same in this case, but the legs would actually flip. If we were focusing on this 60-degree angle down here, this would become the opposite leg, and this would become the adjacent leg. But as it is, with the way ours was written, we're focusing on this 30-degree angle as our featured angle, so we have opposite and adjacent. All right, so step number one is done. So step number two, we're going to cross off the unlabeled side. Notice the hypotenuse side here has a clear label. It's 15. Okay, well, I'll say it's 15 inches. This just says 15. And the opposite leg is also labeled here with the X. This is the side that we're trying to find. But notice that this adjacent leg right here has no label. We do not know how long it is, and frankly, we're not even trying to figure out how long it is. We're going to cross that off. I call this the unlabeled side. In this case, it was adjacent. Now, step number three, we're going to choose between sine, cosine, or tangent. So look at the two sides that I'm left with. I crossed off the adjacent. I'm left with an opposite leg and the hypotenuse. Well, these are the three most famous trig identities in all of trigonometry: sine, cosine, and tangent. And if you look, only one of these uses the ratio of the opposite leg and the hypotenuse. And look, it's sine here. Sine is the only one of these three ratios that uses opposite and hypotenuse. And since those are the two sides that I've left uncrossed, opposite and hypotenuse, I'm going to use sine here. So let me write that down. I'm choosing sine in this case, and I'm going to write down this ratio. So sine is this ratio of the opposite leg divided by the hypotenuse. That's what I'm going to use in this particular example. Oh, okay, here we go. So cross that off. Step number 4, the last step, plug in the numbers and solve. So we've already identified that the theta is 30 degrees. I'll write it over here. So I'm going to plug in 30 degrees for theta. Now you can put a degree symbol here if you want, although in our calculator we're just going to type it in as a 30. We've already identified that the opposite leg is this x, and we've already identified that the hypotenuse is this 15. Okay, so now I have this really equation. Let me write it down here so we can see it a little better. We have this equation and we just need to solve for x. The way we're going to solve for x here, we're actually going to multiply both sides by 15. And x is just going to be, that will get rid of our little fraction here. X is just going to be 15 times the sine of 30. So I'll plug that in my calculator. Now, quick note, you do want to make sure your calculator is in what's called degree mode. With majority of your calculators, this is the default mode, is this degree mode. Although on your graphing calculators, TI-82 and TI-83, TI-84, you might actually have to hit the mode button to switch from radians to degrees. But in my calculator, it's in degree mode. So I type 15 times the sine of 30. The 30 degrees will go in parentheses here. Since I'm in degree mode, this will treat this as 30 degrees. 7.5 is my answer. 7.5 is equal to x. And so if this hypotenuse here was 15 inches, then this, and this is a 30-degree angle, then this opposite leg over here, 7.5 inches. So now let's do a question directly off of your assignment. Here's question number 5 from your assignment. Step 1, label hypotenuse, opposite, and adjacent. Well, always start with the hypotenuse. The hypotenuse is our longest side, is farthest away from our 90-degree angle. And by the way, this whole, what I'm teaching right here, this only applies to right triangles. You have to have a 90-degree angle triangle for this to even work. Okay? And then we're going to make this 49-degree angle is the angle that they give us. We're going to make that our featured angle. We're going to say that theta is equal to 49 degrees. Now, you could figure it out that, let's see, this angle over here is actually 41 degrees. And so in another world, they might have given us this 41-degree angle, but that's not what happened here. They gave us this 49-degree angle. That's what we're going to feature. And so since we're featuring this 49-degree angle, that would make this leg the opposite leg. It's far away from 49. And it would make this leg down here the adjacent leg. So step 1 is done. Step 2, then we're going to cross. This is the easiest, I think. Cross off the unlabeled side. My hypotenuse is labeled with an x. My adjacent side is labeled with this 4, but my opposite side has no label. We're going to cross it off. We're going to get rid of it. Okay, we don't know how long this side is, and we don't care to know. We don't need to know. I'm going to cross it off. Step 3 now, I need to choose between sine, cosine, and tangent. Now notice here, I crossed off my opposite leg, so I'm left with the adjacent leg and the hypotenuse. We'll come back here to my, my 3 trig identities. The only one of these 3 that uses adjacent and hypotenuse is the cosine. So I'm going to go with cosine. Now, by the way, there's a little saying that can help you remember how these go. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, in this case, we're going to use cosine then. But the little saying is SOHCAHTOA. A little saying to help you remember what these trig identities are. SOHCAHTOA. Sine, cosine, and tangent. All right, so this one, we are choosing cosine. So then we're going to plug in our numbers and solve. So cosine, let me write down the original formula or ratio for cosine. That's what it looks like off the formula sheet. Let's start plugging in our numbers. We already said theta is this 49-degree angle. And remember, theta always has to be, theta will never be the 90-degree angle. That's not allowed. It's always going to be one of these acute angles, in this case the 49. The adjacent side is this 4 here. And the hypotenuse then is this x. And so we need to solve this equation. Now you'll notice here, this equation is unique from the previous one in that x is on the bottom of the equation. Go back to our last example. If x is ever on top of your equation like this, then you're simply going to multiply. You're going to take the 15 times the sine of 30. However, if x is on the bottom of your fraction, what you're going to do is do this little switcheroo. You're actually going to flip the x with the cosine of 49. And what you're actually doing, you're multiplying the x to the left, but then you have to divide the cosine of 49 to the right. So I like to just think of it as the little switcheroo here. If x is on the bottom of this fraction, we can just switch these values. The x and the cosine of 49 get flipped. So I need to type into my calculator, I must do 4 divided by the cosine of 49, the 49 in parentheses. It is 6.097. It's actually an irrational number. So we have to look at our directions. The directions up here said always round to the nearest tenth of 1 decimal place. Okay, so this is a 0 right here. But since the number to its right is a 9, that means I need to round this 0 up to a 1. I'm going to write my final answer as 6.1. To the nearest tenth, 6.1. Rounding is going to be really important in this assignment because Canvas is going to require that you round this properly. So just make sure you're rounding to 1 decimal place. Don't write 6.097 or 6.09 or anything like that. It needs to be 6.1 to 1 decimal place. Don't just write 6. It needs to be 6.1 to the nearest 1 decimal place. All right, so that's my answer to that one. You know what? Let's just kind of do a quick look at question 6. So step 1, I label my hypotenuse. Zoom in on this one a little bit. I label my hypotenuse. So here my featured angle is this 53 degrees. I'm going to say theta is the 53-degree angle. That's what's featured, and since 53 is featured, that would make the 11 opposite of the 53-degree angle, and the x would be the adjacent leg to the 53-degree angle. All right, I'm going to cross off my unlabeled side. This hypotenuse is not labeled. It doesn't have an x, and it doesn't have a number. So I cross off the hypotenuse. I'm going to choose my correct between sine, cosine, and tangent. So this one's going to be tangent because tangent is opposite over adjacent. And look, that's what I'm left with here. When I cross off the hypotenuse, I'm left with opposite over adjacent. So this is going to be a tangent problem. So let me write down the formula for tangent, and then we'll start plugging these numbers in. The tangent theta is 53, is opposite over adjacent. So the 11 would have to go on the top, and the x would go on the bottom. So here's another case where the x is on the bottom, and this can happen either way. Sometimes the x will end up on the top, sometimes it'll end up on the bottom. When it's on the bottom, this is where we do the old flipperoo. We're going to take 11 divided by the tangent of 53. And final answer, 11 divided by tangent 53. So it's 8.289. We're going to round to the nearest tenth. So I'm going to take this 2. And I'm going to look at the number to its right. Since this number to the right of the 2 is 5 or greater, that means we're going to round the 2 up to a 3. And this is going to be 8.3. It is an irrational number, but the directions are very clear. We're just allowed to round this 8.3. So the last example I want to look at is question 9. What are we supposed to do if we're missing the angle, if we don't know what theta is equal to? Here we have a question mark for this angle. We can say that theta is unknown. How exactly are we supposed to handle that? Well, we're going to start, the steps really are still the same 4 steps. We're going to start by labeling the hypotenuse as the 56. And then since we're trying to find this angle right here, this is the angle we're trying to find. We're going to make this our featured angle. We're going to say the 47 is opposite of our featured angle. And then this leg down here that doesn't have a label, it would be the adjacent leg. It would be adjacent to the question mark angle. Okay, so here we've labeled the triangle, and then we're going to cross off the unlabeled side. So the hypotenuse has a label, 56. The opposite has a label, 47. The adjacent has no label. We're going to cross it off. So now we need to choose. We're left with opposite and hypotenuse. So we need to choose one of these three featured trig identities. The only one that uses opposite and hypotenuse is sine. So I'm going to choose the sine identity. And then we'll plug in the numbers that I know. Now, here, theta is unknown. We don't know what the angle is. So technically, you can put an x there in for the angle. We don't know what it is. But we do know the opposite is 47, and the hypotenuse is 56. So how do we solve for x in a case like this? We looked at how to solve for x if it's on top of the fraction. We looked at how to solve for x if it's on the bottom of the fraction. What if x is the angle? What if you don't know what the angle is? Well, the way you solve it, so, you know, ideally you'd think, well, maybe is there some way I can divide this sine away? You know, you might be thinking, and technically there is no way to like divide the sine away to make it disappear from both sides. But there is something called inverse sine. And it looks like this. Cross that out. We're going to take the inverse sine of both sides of this equation. Okay, and it's actually the sine symbol with a little -1 after it. This is called inverse sine. And inverse sine is used to find missing angles. Used to find missing angles. So it actually works like this. When we take the inverse sine of both sides of this equation, the inverse sine actually cancels out the sine and leaves you with an x. And now on this side, what we have to do is find the inverse sine of this fraction, 47 divided by 56. Now, any scientific calculator will have this. I know even like Google Calculator on your laptops will have this. If you're having trouble finding this on a calculator, I know you can do it on Google. But so on my calculator here, it's above my sine button in purple. My sine button is here, so above that is this purple sine of -1. That's inverse sine. So I press inverse sine. I'm going to type in my fraction as a division problem, 47 divided by 56. Hit enter. And this will tell me the angle. The angle is 57.064 degrees. Now the directions here actually say, read the directions carefully, this actually says round to the nearest whole number. So we're going to say just 57. X equals 57 degrees. It says numerical answer only, do not put a degree symbol in your answer. So technically the answer is 57 degrees. In Canvas though, we're just going to type that as a 57. If this is a 56 and this is a 47, this angle right here, this featured angle theta, is going to be 57 degrees. And while we're here, let's look at the very last question. Oh, sorry, not the very last question. Let's look at question 12. So what are you supposed to do if you have all three of these sides? You know, you can still label this would be hypotenuse. The leg farthest away from my question mark is 36. The leg closest to my question mark is the 27. That's adjacent. So what are you supposed to do in a question like question 12 if you have all three of these sides? It's which one am I supposed to cross off? Well, the answer is, in a case like this, if you're given all three of the sides, you actually get to choose which one you want to cross off. So we're just going to pick one randomly. I'm just going to say, all right, I'm going to pretend like I don't know what this adjacent leg is. I'm going to pretend like I don't know that's a 27. I'm going to cross it off, or you can say I'm going to cover it up if you'd like to. And so I chose to make this a sine problem. I'd say the sine of this missing angle is opposite over hypotenuse. So then I can use inverse sine to figure this out. All right, so we just did a lot of examples there. I know this is like a 20-minute video, so I'm going to end this video here. These were the examples. I'm also going to post a second video in this lesson that gives you some of the backstory of sine and cosine and theta. If you're interested, I will post that as a separate, just kind of supplemental video. Best of luck on your assignment. Take care. Bye.